In this video, we're going to talk about thermodynamic processes. We will next look at 4 different types of thermodynamic processes and their effects on the internal energy of a thermodynamic system. Each process takes place in a situation where a particular thermodynamic quantity is fixed. The first one we'll talk about is isothermal, which means we keep it at constant temperature. Isobaric means constant pressure. Isochoric means no change in volume. Adiabatic means no heat is added or removed from the system. In an isothermal process, the temperature remains constant. In other words, delta T equals 0. For an ideal gas, since the internal energy U depends on the temperature T, the internal energy remains constant. In other words, delta U equals 0. Since delta U is equal to Q plus W prime, where again, remember, W prime is the work being done by the external pressure on the system. The heat transferred is equal to negative W prime. All heat added to the system is converted to work done by the system. In an isobaric process, the pressure is constant. Since the work done is done by the external pressure times the change in volume, work is done as soon as the volume changes. Since T is allowed to change, delta U is no longer equal to 0. Since delta U is equal to Q plus W prime, it can be arranged, and the heat is equal to the internal energy minus the work being done on the system. Heat added to the system causes the system to do work and will increase its internal temperature, and therefore T. In an isochoric process, the volume is constant. In other words, delta V equals 0. This means that the pressure and temperature, and therefore U, the internal energy, must change. Since the work is equal to the pressure times the change in volume, the work done is 0, so no work is done. That means that the total change in internal energy is related to the heat. So heat added to the system increases the system's internal energy. In an adiabatic process, no heat enters or leaves the system. So in other words, Q equals 0. Since Q equals 0, any work done on the system increases its internal energy. Any work done by the system decreases its internal energy. In other words, delta U is equal to W prime. Notice here it shows the adiabatic process goes from one isotherm to another isotherm. The area under the curve is the work being done. So here is a summary of your thermodynamic processes. If it's isothermal, delta T equals 0, delta U equals 0. That means that 0 is equal to Q plus W prime. In an isobaric system, delta P equals 0. That means delta U is equal to Q plus W prime. In an isochoric process, delta V is 0, and that means the work done by the external pressure is 0. And that means that the internal energy change is due to the heat added to the system. In an adiabatic process, the heat is 0, and therefore any change in the internal energy of the system is related to the work being done on the gas. A sample of an ideal gas is taken through a closed loop. Which of the following is true about the change in internal energy and work done on the gas between points 2 and 3? A, the change in internal energy is 0. The work done by the external pressure is greater than 0. B, the change in internal energy is 0. The work done by the external gas or external pressure is 0. C, the change in internal energy is 0. The work done by the external pressure is less than 0. D, the change in internal energy is greater than 0. The work being done on the gas is greater than 0. E, the change in internal energy is less than 0, and the work being done by the external force is less than 0. Okay, so let's go ahead and take a look at our answer. The correct answer is C. The internal energy is constant because we're traveling on an isotherm. Work prime is going to be less than 0 because the gas is doing the work. How do we know that? Because your volume is increasing. A sample of an ideal gas is taken through a closed cycle. Which of the following is true about the change in internal energy and work done on the gas between points 1 and 2? Is it A, where the internal energy is 0 and the work being done is greater than 0? B, the change in internal energy is greater than 0 and the work done is 0? C, the change in internal energy is 0 and the work done is less than 0? D, the change in internal energy is greater than 0 and the work done is greater than 0? E, the change in internal energy is less than 0 and the work done is less than 0. Okay, so let's take a look at the answer. The correct answer is B. You had to choose this because there's no work being done. There's no change in the volume, and therefore the only answer that can be correct is B. In the next video, we'll talk about the second law of thermodynamics.